Hi, and welcome back. So you might notice that there's a slight difference in the appearance of my recorded screen. Why? It's because Jupyter Notebook has been acting up on me. So next best the next best thing for me to use is actually Google Colab. So Google Colab in a sense is very much like Jupyter Notebook, but you run these notebooks on Google's cloud service. So the point of the whole infrastructure of Google trying to provide cloud services to the Google users, especially those who are interested in data science, machine learning, deep learning, and so on and so forth, is because they eventually want people to use their platforms. So since our university is actually a partner with Google, and then most of our infrastructure, digital infrastructure is very much tied up with Google anyway. So I figured, why don't we use Colab, right? So the way that you use Colab is that you try to connect it to your Google Drive, and then open Google Colab, make the connection there, and then you can open the .ipynb files. So I'm sorry, I haven't thought of this before because I initially asked everyone to install a Jupyter Notebook, and in some ways I still prefer Jupyter Notebook, but for the purpose of this lecture, and since my device isn't really cooperating very well with PyDroid, we shall use this as an alternative, and you can too. Okay, so the conditions and statements are as follows. Okay, so yeah, we last stopped at tuples, right? And then you can see in Google Colab, you can click on the hidden cell and then we can run it. Okay, so this is the output, slightly different from the usual stuff that we are used to. Okay, so conditions and statements, we have the ability of Python that gives the user the possibility of running pieces of code only when a specific condition is met. Okay, for example, the simplest way for us to check for conditions is actually the if and else statement. It evaluates a proposition and executes the next chunk of code based on whether the statement is true or false. Okay, so a very simple example is as such. We assign values to variables x and y, and then that is followed by using the if statement introduced by using the keyword, followed by the condition x is less than y. So this is our initial condition that we put to be tested inside of our code. Okay, so there are two outcomes with an if else statement. The first outcome, if this statement is true, if x is indeed smaller than y, then we execute the first block of code. Or else, if it is false, the block of code that follows the keyword else is executed. Now, if there is no keyword else keyword to be found, right? After the if statement and the condition is false, the code written inside the statement will be ignored. Why is this doing this? Okay. Inside. Gosh. Okay, so for all it's worth, I can't really delete. It has trouble trying to detect my... Okay. Yeah. You know what I mean. So, actually, let us just move on to the next piece of code. Okay, so it's written inside the statement. Yeah, one thing that I found with Google Colab is actually editing is a little bit tricky, but it's okay as long as we can proceed, right? So before we move on with if-else statements or if, ELIF, and else, ELIF is actually a shorthand notation for else if. Else if is actually found a lot in C++ and also the legacy programming languages, right? But then here in Python, it's shortened to ELIF. So you have if, ELIF, and else. That's for statements that can result in more than two outcomes. So in our case, the if-else statement is actually an ideal place to start. However, before we move on to if-else, if, ELIF, else, we need to understand one thing, which is Python indentation. Okay, so in Python, the indentation is used to specify blocks of code and is therefore very, very important in order for us to make the code work, right? So note that in line 5 of this code snippet, this here is an indentation, right? So notice that if I, probably you won't have this in Jupyter, but then here in Colab, right, you can click the if statement and then it will roll up to hide the code block that will be executed if we find that the statement is true, right? So an indentation is actually very easily achieved by typing one tab. You need to press the tab button once in order to create an indent. Okay, and then this is the if statement. If the if statement is found to be false, we need to run the else statement instead, the code of block after the else statement. Okay, so here we can see that our conditional statement is here. We are checking whether x is less than y, right? And then we have somehow designated x equals to 8 and y equals to 5. So it is very, very apparent that actually x is not smaller than y. So by simple logic, you would see that actually x is indeed greater than y. To confirm this, I'll run this. Yeah. So in Colab, you need to press the play button so that you can get the outcome. So yes, it has confirmed our theory that actually x is indeed greater than y. Why? Because this statement is false. So when the first statement is false, it goes automatically to the second statement, which is the else statement, and it runs the code that comes after the else statement, right? Let's see if we can change this and see how the code changes, right? So let's just change y to 11, shall we? So thankfully, we can edit the code inside, right? So in this case, when x is 8 and y is 11, so this confirms our initial assumption that x is indeed smaller than y, because y is 11, x is 8, so this would make line number 5 correct, isn't it? But just for confirmation, let's just run this, see how this goes real quick. Yes, since line number 5 is found to be true, we run this line here, line number 6, x is smaller than y, and voila. So that is a good intro to if-else statements. If-else, okay? So in other types of condition testing, we find that in Python, all the usual logical conditions found in mathematics applies, where a and b are two predefined variables, say x and y. It's similar to the x and y that we defined previously, okay? So you can make the same assumptions. Say, for example, we are testing X is, sorry, A is 8 and B is 11, right? So we first check whether A is equal to B or otherwise. So since A is 8 and B is 11, so this is not correct. You can also say that A is not equal to B by putting an exclamation mark before the equal sign. When you are assigning a value to a certain variable, you use the single equal sign, but when we want to test for conditions, you need to use double equal signs. All right? Okay, so the other types of conditions apply when we have A is greater than B, when A is greater than or equal to B, A is less than B, or A is less than or equal to B. Okay? So again, I'd like to emphasize a common mistake that inexperienced programmers make is that they usually forget to use two equal signs like this to specify that the equals condition is being tested, right? If you use one equal sign only, you are changing the value of A to that of B, right? So in this case, if you use just one singular line, A equals to B, right? Then A is 8, Y is 11, B is 11, and A is equal to B, and then you print out A, it's going to show that A is going to end up as 11. Because the initial value of B is 11, and then now that you've equated A, you've assigned the value of A similar to that of B. So instead of comparing, you have now assigned A to a new value. So that's not what we want. Okay, so be very, very careful with the use of equals. The equal sign, is it single equal sign or double equal signs? Okay, so not as a conditional statement. So when I end my sentences with an exclamation mark, it's not that I'm mad at you, it's just, yeah, it's just me trying to sound excited, yeah, and me trying to make a point. I'm not mad at you, okay? I know how texting is among the younger generation, and you're very sensitive to the font changes, yeah. And then like this one, like the not, I'm not really shouting, okay? It's just a way for me to emphasize things, okay? So don't take it personally, thanks. Okay, so like I mentioned previously, just now we were introduced to the if statement, and now we have the second type of statement, which is the ELIF statement. Okay, so what if we want to specify more if statements one after another, right? If we have more than two outcomes, it's no longer true or false, right? So this is where the ELIF statement steps in. So the ELIF statement, it uses the same syntax as the if statement and can be called as many times necessary, which means in between the initial if and also the closing else, you can have as many ELIFs as you want, right? So the ELIF chain can be closed by an optional else statement that will be executed if all of the conditions written before the else statement or before the last ELIF statement resulted to be false. So let's just see. Right, so we are going back to our roots. So if you remember, and if you still can recall, the Young's modulus value of steel is actually, it's around 210,000, right? So this is an example of ELIF statement where we have more than two outcomes. Usually the outcome is just true and false, but then now we have more possibilities to take into account, right? So here we have a dictionary called Beam, and it has a key, right? How do I know it's a dictionary? Because of the curly braces. Since the curly braces aren't found inside of a string, so it's not a formatting of a string, but instead it's a dictionary, right? So in a dictionary, you will always have a key on the left and its value on the right. So in this Beam dictionary, we have two keys, which is mat, which stands for material, not matrix, mind you. So the material is steel, the value steel, and then you have the E, which is the Young's modulus, with a value of 210,000, right? So now that we've established our dictionary, let us put the Beam keys, and we call upon the Beam keys. In this case, it's the material. We try to extract the value of the key, and then we try to see, using the double equal sign, whether the material is steel, concrete, wood, or anything else, right? So if you don't mind, I'll just go through this line by line. Now that we know that the material is actually steel, we automatically know that the line in number 4, line number 4 shows you if the material, the key material inside the Beam dictionary is equal to concrete, we would print out this is a concrete beam. But we know for sure that line number 4 is false. So we skip to line number 6. We close this and we go to line number 6. Else, if the beam material is equal to steel, then we print out this is a steel beam, right? As I've mentioned before, if you have some doubts on the outcome of a certain code block, right, I would usually share the answer with you in the comment at the very last line of a given code block, okay? So you would find that if we run this code, that it is indeed correct. That we would find that the printout shows this is a steel beam. Why? Because at line number 6, we find that the conditional statement that has been evaluated evaluates to true. Therefore, it prints out line number 7. So upon the printing out of line number 7, the if, elif, and else statement is terminated and it goes outside of the entire statement entirely. So it starts off with the dictionary at line 2, it goes through line number 4. Since it's false, it goes to line number 6. And since line number 6 is true, it prints out line number 7 and out it goes. So the code terminates after we see this is a steel beam. Okay, so moving on, logical operators. It is used to combine multiple conditions together. So let's just see the code cells that we have here. Okay, so the first line is a shorthand notation used to assign a set of values to a set of variables. If you can recall previously, we have x equals to 8 and y equals to 11. So these variables are defined using different lines. Also, to make your codes look sleeker and you use less lines of code, you can actually write it in shorthand notation. So shorthand notation looks like this. You have the A, B, and C variables which correspond to 1, 2, and 3, right? So yeah, it simply stores 1 in A, 2 in B, and 3 in C. And in line number 3, we see the logical operator AND. Can you see? This is the logical operator AND. This operator returns true only when both conditions associated with it are true, right? So true and true, it becomes true. In this case, since conditions A less than B A is less than B and B is less than C are indeed both true, the code inside the if statement is executed. Okay, so just to see, you can see that I have included the code with some comments so that you can have a better understanding of what is going on in every single line of code. Yeah. So since true and true, we print this out, right? What happens? Yeah. You can see that actually in this code here, it's missing an else statement. That is how confident we are with our if statement, which is true because we did not provide a supporting else statement. In actual fact, you would actually have to put in an else statement, right? What happens if it's false, right? So see, when we modify the original code block here, and then we make one statement true and one statement false, what happens is what we see in the following code block. So in this second code block, ABC is still 1, 2, 3, and then we change the condition slightly by changing the B is more than C, right? And then we change the logical operator from and to or, right? So now statement 1 is true, or B is more than C. B is not more than C, which is false, right? So true or false. For logical operator or, it returns true if at least one of the two statements is true. So unlike and, which needs both statements to be true for it to print out the corresponding code block, line of code after the logical operator has been evaluated. You see, when we are dealing with true or false, when it is true or false, it will still yield us a result of A less than B and less than C. Okay, so when we run this, you would find that actually A less than B is true, or B is more than C is false. But since either one of the statements can be true in order for us to print out this one, you can see that there is some flaw in this code block, right? Because it uses the or logical operator. So use these three logical operators with caution, because if you're not careful of the outcome and it doesn't follow logical statements, you would find that actually you might not have the intended outcome that you wanted in the first place. Okay, so there's this subchapter called shorthand notation. Okay, honestly, I'm not really a fan of shorthand notation, because as you can see here, there's this one, right? Yeah, it basically shows you the if, else, and if ELIF statements written in a single line, right? I personally feel that this is something that computer scientists would be thrilled to explore, but in the purpose of us learning the basics of Python, I don't think this is necessary actually, right? So I'm gonna skip this, but feel free to explore it on your own. But honestly, if you wrote your if-else statement or ELIF statements in the usual way, meaning you have multiple lines like this, I wouldn't mind. I don't need you to rewrite things in shorthand notation, okay? The conventional way of writing if, else, and ELIF statements are acceptable to me, okay? So I'll just skip this part and let's move on to Python operators, okay? So an operator is simply a keyword that performs a certain operation on a given value. So you have 7 types of operators. Some operators we have already covered in previous subchapters, right? So for example, arithmetic operators, you have the basic mathematical operations that we all know. Okay, so this table is actually very nicely, it looks nice like this because it has some underlying formatting, which you will actually learn, I think, in data frames, if I'm not mistaken. It's okay. It's not compulsory for you to know the inner workings of how this is. I see. So yeah, it just uses simple, some HTML type of formatting. So it's not even data frames or some sort. Okay. So here we have the operator, the usual addition, subtraction, multiplication, division, modulus, exponentiation, and also floor. Right, so we have an example of x equals to 13 and y equals to 4, right? So the first 4 is probably very familiar to all of you. Okay, so I'll just very quickly go through the last 3 operators. So modulus is what you will get when you divide x with y and you have the leftover value. So when you divide 13 with 14, yes, so 4 times 3 is actually 12. So you have 1 left over, which is why the modulus is resulting in the value of 1. And we have the exponentiation here, whereby we take the number 13 and we raise it to the power of 4, which will result in 28,561. Okay, and notice that the exponentiation is performed using 2 multiplication symbols, or as I like to call it, double star. We are not using the top hat symbol like in other programming languages. Yeah, if you're coming from C++, as I would imagine, this is what we used to use to denote raising the number to a certain power. But now that we are dealing with Python, you would use the double multiplication symbols instead. Okay, last but not least, floor is when you take 13 and you divide it by 4. Right, so when you take 13 and you divide it by 4, you get a number 3 point something something, isn't it? Yeah, so it's more than 3, and it has it is more than 3, but using the floor operator you would round down that number so it becomes 3 instead, which is why you get 3. When you use the ceiling operator, which is not really included in here, but then you can feel free to explore it on your own. When you use ceiling, it would round up the value instead. Okay, so floor and ceiling are pretty much opposites to each other. So when you take 13 divided by 4, it's 3 point something something, and then you round it down and it becomes 3. Okay, so that's arithmetic operators. So okay, I'll move on. Assignment operators. You can see that we're heading towards the end now, so the end is near. Don't worry. So we're approaching the half an hour mark. I hope you are still here with me. You're listening to me at 1.5 speed. Good luck, because I think I do speak a little bit fast, but it's okay. You can slow it down as you please. since this is YouTube and all. Okay. What are assignment operators? So Python assignment operators are a form of shorthand notation that can be used when we want to perform an operation on a single variable and assign the result to that same variable. So this operation is shown in the next code cell, which is this one, right? So we have an initial value of x equals to 3, and we print out the value of x, so it becomes 3 here, right? So what if we want to assign the value of x right after we declare x is a given number, which is 3 in this case, right? So say we want to add 2 to the original x, so we write this down, x equals to x plus 2. So the result of x plus 2 is stored in x. So the original x is overwritten, right? Like when you want to save different versions of the Microsoft Word file, right? So this one, it takes the original value and it does a certain operation and it saves the new value. It updates the new value, okay? So when we print it again, you would find that in line number 5, you would give a new number. So here, when we run this code, yes, it will come out as 3 and 5. You would see the difference between the initial value of x, which is 3, and the second value of x, which is 5. Okay? So that is an example of, well, it's not really an assignment operator. Let's go see what an assignment operator really is. It's actually contained in this next code block, right? Because this one is just us reiterating or repeating the x variable twice, right? So we declare it in line 2 and then we assign x to x plus 2. So what actually there's a more elegant way of writing this, which is using assignment operators. Assignment operators perform this exact same task, except it uses less code. How is there less code? Well, actually, this is the example in this code snippet that we have here. So we have x equals to 3. So line number 2 and line number 3 are actually pretty much the same as the previous code block, sorry. But we actually have something new here, which means x plus 2. When you change x plus 2, okay, so x plus equals to 2. This means that the initial x that we have will be added with 2 and it saves the value of x that we have after the operation is done. Okay, so let's just run this code real quick. So you'd find that actually this code block and this code block are the same, except that it uses, well, it actually uses one less character is all, because essentially in line number 4 what you're doing is actually you're shifting this plus sign to the front and you're eliminating this x in the middle in order for you to create something that is called an assignment operator. You're using a mathematical operator, but you're also simultaneously assigning the variable to update its value after the operation has been done. Okay, so previously you saw, what if we used different types of different types of operations? So you can also use it with, say, division. Okay, if 3 is divided by 2, it's going to come out as 1.5. What if we multiplied it? So 3 times 2, it becomes 6, right? Yep. Okay. So it works with all of the operators that we can see. So let me change this real quick to the original, which is plus. Okay, we run this again to show 3 and 5. Okay, so in line 3, plus equals represents the addition assignment operator. Python provides the user with assignment operators for all of the major mathematical operations. So say we have the initial value of x equals to 3. So the most important operators and the corresponding assignment operators are shown as follows. You have x equals to 3, plus 2 is 5, 3 minus 2 is 1, 3 times 2 is 6, 3 divided by 2 is 1.5, 3 modulus 2 gives 1, sorry, modulus, right? Exponentiation, 3 raised to the power of 2 is 9, and 3 with the expression floor 2 is actually 1, because when we divide 3 with 2 we have 1.5, and then you round it down, it becomes 1, right? So if you want to play around with this with the values within this table, you can actually run this code here, right? And it's going to give you all of the values that you ever wish that you could have, right? So feel free to play around with the values here. Okay. Now, comparison and logical operators, we've already covered this. Kindly refer to the previous section, assignment operators, for an explanation for their usage. Yeah, we did comparison and logical operators during the if-ELIF statement anyway. So yeah. Okay, so now membership operators are used to check if a certain subset of values is present in a larger collection, right? You can also apply this to, you know, the Justice League list if you wish, right? Say you want to check if, say, yeah, any of the superheroes that don't belong in Justice League, are they included? Yeah, so you can, yeah, feel free to change this example of membership operators to check, right? But then, yeah, I'll probably just go back to basics with, you know, a list of numbers and checking if the numbers do belong in the given list. Okay, so for example, they can be used to check whether a certain number appears in a given list. So we have this list called mylist 1 2 3 4 5, and we have two numbers, a equals to 3 and b equals to 12. So it's very apparent to us that at the get-go we can see that a is indeed listed in my list, but somehow b equals to 12 is not included in my list. But do you need Python to tell you that? Yes. Actually, yeah, without actually breaking a sweat, you would be able to write down the code which asks Python, can you really check this for me? Even though, yeah, it's actually as bright as day, but it's okay. Nevertheless, we are trying to check our prowess, our skill in writing inside Python language. The way for us to check whether using the membership operators, does a certain element inside that is defined in a variable, does it belong to a certain position in a list, which is called mylist. Okay, so let's just check this real quick. I'm going to comment out the second part. Okay, let's just run this first part. So if we run this first part, if A is in my list, right? So it's quite apparent that A equals to 3 is actually it is indeed in my list. So you would find that, oh, I'm sorry. There's a syntax error because this is actually the intended outcome. A is in my list. So let's just run this again real quick. If A is in my list, we print out line number 7, right? So it is indeed true that line number 6 is evaluated to true and A is in my list. Okay, so now that's correct. That's been confirmed. Let's go and see what the second part of the code block yields for us. So let's run this. If B is in my list, print B is in my list. However, it's clear as day that B is not in my list. So we will be seeing that line number 11 is actually false. So it goes straight to line number 13. So since line number 13 is else, when line number 11 is true, it runs line number 12, but this is not the case. So we go to line number 13 and we run the subsequent code contained in line number 14. Therefore, we see B is not in my list. It might look trivial now, but then trying to sort a lot of numbers and seeing the occurrences of your data in a lot of lines of code. So you can see that actually this is a very nifty piece of code, okay, to check the number of occurrences of your data, how many times it shows up in your data set. Yeah, so this is where it all starts. Okay, so as we can see, we use the keyword in, right, in, to check if A and B appear in my list. In this case, both A and B are integer numbers. However, membership operators also works with strings, dictionaries, and tuples. Okay, so mind you, it also works on tuples because tuples aren't really things that you can change, but you can check for the count, right? The count and the index number. So in this instance, we're trying to do the membership operation on these type of data structures, strings, dictionaries, and tuples. And this is the list, right? If Python finds an occurrence of the specified value inside the collection, it will return true. So in this case, in this code block, the lines that are true are actually line number 6. And in line number 11, it goes to false, but then, yeah, since this is false, we go to else, right? So there. If you want to check if a subset of values does not occur inside a collection, we can use the keyword not in instead, because previously we used if B in my list. Yeah, it's not really the syntax isn't really adhering to English grammatical rules. Yeah, because if B in my list, I'm pretty sure if you wrote this and your English teacher saw this, they would probably think, what have I done? But then, yeah, this is a programming language. It's very close to English, but not quite 100% English. So please excuse the grammatical mistakes, yeah, because these are actually logical statements, isn't it? So like I said previously, we can use in or not in. So these two instances we can check for the occurrence of certain values within a list, string, dictionary, or tuple. Okay, moving on. For loops. So for loops are used to iterate through a sequence, right? Be it a list, a string, a dictionary, and etc. Or it is to perform a repetitive operation a certain number of times. So a for loop is introduced with the keyword for, as highlighted here in magenta, right? It is followed by an iterator. So the usual iterator that we use in Python is actually I in my list. So we have our dear list here, my list. So it contains some integers 2, 4, 8, and 16. And then what this does is actually the block of code that comes after the for statement is run repeatedly at each iteration of the for cycle. An example is shown as follows. Okay, so when we run this, we have my list, and then we have 2, 4, 8, and 16. So for I in my list, I is actually referring to the index, right? The previous code block, this code block, we create an iterable object, a list called my list. So this list is created by us, line number 2. Then we iterate through that object using a for loop. So this is the for loop that I mentioned. At each iteration, the variable I, the iterator, changes its value to match the one in my list. So since my list has a length of 4, the print command is executed 4 times, 1 for each iteration of the for cycle. So I starts off with this number here, number 2, and then it's going to run again to print out 4, and it's going to run again to print out 8, and lastly 16. So for I in my list, print I, right? So it's going to print every element inside the list until it finishes, which is why you can see 2, 4, 8, and 16. Okay, so a range is something that you would use a lot in this in our textbook. The range function is used to create a sequence of numbers that go from 0 to a certain value and can be very useful in for loops as a way to repeat an operation a specific number of times. Okay, so the following code block, it shows us the use of the range function. So this example uses the range function. For I in range 5, you would find that I actually starts with 0 because I is indeed the index number, and it starts with a 0. It's getting a bit too dark, I'm sorry. Okay, so in this instance here, when we start off with the for I in range 5, it starts with 0, right? So that's why the first printout is actually number 0, and it goes again, prints out number 1, 2, 3, and 4. Now it is important for us to remember that actually the range n function creates a sequence that goes from 0 to n minus 1, not from 0 to n, nor is it from 1 to n. Okay, so usually when you specify range 5, it would be automatically understood that actually your printout would end with the number inside the range 5 minus 1. That's why we see that the printout ended at number 4. Okay, so what if I wanted the printout to end at number 8, right? So using the same logic, I would have the number inside the range to not be 8 because I wanted it to end with 8. Since the sequence goes from 0 to n minus 1, and n minus 1 is equal to 8, I wanted number 8, right? So actually the range here should be number 9. Okay, let's test this out. Let's see. Yes, so initially I wanted the printout for I in range to end with number 8, and since the range n function creates a sequence that goes from 0 to n minus 1. If I wanted it to end with number 8, I needed to find a number inside the range that is actually the end of the printout plus 1. So it's number 9. Say, what if I wanted it to end at number 12, right? So here, I will put in 13. Okay, so I guess this is pretty easy for you. Okay, so let's go and see something that's a little bit more complex, right? So let's see this code block here. The range function is continued. So previously we learned that when we specify a number as the range, the number in the range doesn't necessarily represent the last number that you'll see for this code block. In fact, it is this number minus 1, which is 12. Now in this case, for this code block, we will go through the code line by line. Okay, so in line number 2, again, we created mylist 2, 4, 8, 16. Okay, and then in line number 3, we created something called the len function. So the len function returns the length of any iterable object that we pass to it. So this is an iterable object with 2, 4, 8, and 16. Okay, in this example, since my list has 4 elements, right, you can see that the list underscore length equals to len in run brackets my list. It would give you a value of 4, right, which is then stored inside the variable list length, right? We created a new variable list underscore length, and we assigned the value of the length of this iterable object. Since it has 4 elements, 1, 2, 3, and 4, the length actually is equal to 4. Okay. Therefore, here is something new, or to confirm the theory. Let us see what happens when we print out list length. It actually is equal to 4, right? Okay, so now that's confirmed. Let's go run the code here, shall we? So for I in range, so notice that just now we specifically put in a number, right? So now we are using a variable instead. So for I in range 4, right? So when we print my list I, it goes from 2, 4, 8, and 16. When we invoke the for loop in line number 4, actually it's line number 5, we pass the list underscore length to the range function. Therefore, we are creating a for loop, thus creating a for loop that iterates from 0 to 3, because we have 0, 1, 2, and 3. So please distinguish the iteration 0, 1, 2, 3 and the length, which is 4, because 4 elements is what we have, but the index number goes from 0 to 3 because there's 4 elements. The iterator I can then be used to access each element of my list one after the other. So when you use print my list, so this list here, and you directly reference the I, the iterator, or the index number. So I starts with 0, so we print out 2, then we print out 4, 8, and 16. Okay. So again, this proves our theory is correct. Okay. So now let's go on to something that is, I don't know if you would call it fun, but then I think it's important to include moments of levity sometimes in class, right? So here we have Bart Simpson. I think this is the very first episode of The Simpsons. Simpsons have been on air since 1985 or 84, I'm not so sure. Right? So it's been ages since its first airing. So this is actually from, yeah, the very first episode, like I said. So actually, I have a challenge for you. Can you replicate "I will not waste chalk" 10 times written on the blackboard using the for statement or the for function? Right? So in here is the Bart Simpson's meme. Okay, so I have the answer down here. So if you'd like to challenge yourself, if I were you, I'd pause this video right here and try to write out the for loop just to see how much you understand from what we have learned in the past few minutes. However, if you feel like you're not really up for a challenge, it's okay. I'll just move on and explain my answer. Okay, so here it's quite easy. Initially, it was just this, right? Oh. So initially my answer was just "I will not waste chalk." But then I think in class, one of your friends actually stepped up to the challenge and added some more things, like "I" plus 1. Oh. So apparently this Bluetooth keyboard has a habit of typing things twice. So here, when we modify the code, you will find that print "I", oh, comma, sorry. There's a comma here. Oh, my apologies. So there's "I" here, and there's a comma right here. Oh, there it is. Let's run this again. Okay, so "I will not waste chalk" 10 times. So by the power of range 10. Okay, so I will not waste chalk 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the reason why we have 10 times while the range is 10 is actually because the "I" actually initially started with 0 and plus 1. Actually, the range goes from 0 to 9, right? But the number of instances that we have is actually 10. Because it starts here, index number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So you have index 0 to index 9, but then the numbers update from 1 to 10. This is easily achieved when you take the iterator and you add plus 1 to it, so that it will start with 1 instead of 0. That's it. Okay. So actually, one thing that I didn't really go into very deeply just now is actually the use of break and continue statements. So using the break statement, we can stop a loop at a certain iteration. Now, something that is fairly common for people who are using for loops for the first time, they might be caught in what's called an infinite loop. So what happens during an infinite loop is that every time the loop runs, it will run every single time to infinity because of the condition inside the for loop that never turns false. So what happens is, if you have an infinite loop ongoing, you can totally stop the program from running, or eventually it will run out of RAM eventually. But don't worry if you have executed an infinite loop somehow or other during the process of you getting better, it's okay. I'm telling you, it's okay. You just need to stop the kernel, restart the kernel, okay? So make sure in order for you to absolutely avoid any occurrences of an infinite loop, make sure at some point when you are running the loop, it will turn false at a certain point, or else you would have to stop it when it runs out of memory, right? Or you'd have to stop it manually, okay? So in this case, using the break statement, we can stop a loop at a certain iteration as we see fit. Like, for example, we have for I in range 5. So this means it will stop at number 4, right? But then we interrupted this for loop because inside this for loop there's an if statement. If I is equal to 3, then you break. Which means when the value of the iterator is equal to 3, we stop the for loop and it goes outside of the loop and it terminates. So meaning when the loop is stopped, you will not see I printed out to number 4. Because, well, originally if line number 3 and line number 4 did not exist, right? This for loop would run from 0, 1, 2, 3, and 4 because it ends at range 5, right? So when you look at the printout, it's supposed to end with 0, 1, 2, 3, 4. Right? However, we have this one new thing here, which is the if statement. Inside, when it goes to I equals to 3, it breaks. Therefore, you only see the printout of the first few iterations, which is 0, 1, and 2. Okay, again, we run this just to see, just to make a point, and yes, 0, 1, and 2. What if I wanted to change if I equals to 4? What would happen? So the I would be printed out from 0, 1, 2, 3. Okay? So it prints out everything except for the last number. So in this code block, the loop is interrupted as soon as I is equal to 3. Any code inside the for loop that comes after the break statement is ignored. So if this is true, then we run this break statement. Therefore, line number 5 is totally ignored and it goes out of the loop. It stops the loop. Okay. However, the second keyword that we are learning today is actually the continue keyword, is used to jump to the next iteration to the cycle. See what happens here? We have for I in range 5, and then instead of the I equals to 3 and we break, we continue instead. So when I is equal to 3, the print order for that iteration is ignored. Meaning, since we put in continue when I is equal to 3 is achieved, we ignore line number 5 because of the print I. But then, since we continue, this line number 5 is ignored and the for loop runs again until it reaches range 5, which is when it ends at number 4. So the print order for that iteration again is ignored because of the print I line comes after the continue statement. So anything that comes after the continue statement or the break statement is ignored. In the case of continue, it doesn't exit the loop, it continues the loop until the range requirement is satisfied. Program jumps at the next iteration where I is equal to 4. Right? So that is the difference between break and continue. Okay, so this is the culmination of the things that we've been wanting to learn for the rest of the subchapters that we've covered. Actually, everything comes together very nicely in this very last subchapter. Yeah. Believe me, if you read other textbooks, you would find that yes, the things that I've covered in this chapter are actually excerpts from different chapters combined into one. So I need you. I don't really need you. I think you can commend yourself for being able to pick up on things from other chapters quite adept in an adept manner, right? Seeing as I have just hit 1 hour and 5 minutes, okay? I hope this won't take too long. Okay, so we have functions, variable scope, function parameters, unpacking, and conclusions. I don't think this will take too long, okay? So functions is the bread and butter of, well, basically any other computer scientist or actually any civil engineer who's very willing to harness the power of programming to their own benefit, okay? So a function is essentially an element that takes some inputs, performs some operations on them, and then returns an output, right? So when you write an algorithm, functions are useful because they save a lot of lines of code and help to conceptualize what the various elements of the program does. So for example, if you are writing a program that calculates beam deflection, perhaps this is a little bit out of your depth, but it's okay. Please stay with me, right? In beam deflection, we need to calculate the moment of inertia of a beam's section, okay? So what we do, how we tackle this problem is that we separate the problem into small chunks of functions that solve certain portions of the moment of inertia calculation, right? So what we do is, in our problem-solving function, we first take the beam's geometrical properties as inputs in our first function. Then, in the second function, we use the inputs to calculate. Oh, this is all within a program. And you can have several functions within a program. Actually, number 1, 2, and 3, they can easily be integrated inside one very complicated function. But then in this case, let's just see how it is done. First, we take the basic geometrical properties as inputs. Then we do some calculation from the inputs to get the moment of inertia, and then the third part is that we take the result and then we return the result as an output of the function. Therefore, every time you want to calculate a moment of inertia, we can simply call the function we previously wrote. So I'll go through a very simple function which calculates the area of a trapezoid, okay? So you have the long base, you have the shorter base, and then you have the height, right? So in this function, a function is usually defined by the keyword def followed by its name. So yeah, let's just put this area here, and then in after the name of the function is defined, you have round brackets, and inside the round brackets you are supposed to list out the inputs that you are using in order for you to use within the function. So for our area function, it takes 3 inputs. B is the bottom base, the capital B is the bottom base, the small b is the top base, and the h is the height of the trapezoid. And therefore, what it does is it returns the area. So notice that we don't have any other calculation steps. We directly use the formula of the area of a given trapezoid and return in the same line as the return function. Notice that after this inputs, there's a semicolon. This introduces the indented block of code. See, this indented block of code here. This is executed when the function is called. In this case, the formula of the trapezoid's area. So for you to call upon a function, you just need to call the name area. Oh, name is area. Why is this happening? Okay. So area, and then in the round brackets, you have 3, 1, and 2, which corresponds to the bottom base, the top base, and also the height. Okay, so the keyword here, return. So you have two keywords here. One is def, which tells Python, hey, I have a formula, I have a function here. And then the second keyword is the return keyword. The return keyword is what you would want to use to tell Python, see, I have this function and this is the output of this function. So I'm returning this to you, okay? So the keyword return is used to specify the output of the function. Whatever follows the keyword is what the function will return. So in this case, we are returning the value of the area of the given trapezoid that we have, right? So in line 3, we see how a function is called. So the function call is actually this part here. Area in parentheses, in round brackets, 3, 1, 2. And when we call the function and passing the inputs, we are also saving it to a new variable called myArea, okay? And the output of the function is stored in a variable called myArea, which is later displayed using the print function written in line 4, actually this number, and 1, 2, 3, 4, 5. So in this last line, we are using our function here, variable here, myArea, and we are printing it out to show that the trapezoid of bottom base 3, top base 1, and height 2 yields an area of 4, right? Just to make sure. Okay, so it's 4. So please take note that we shall not be confused by the fact that area function does not have the variables b, capital B, small b, and h that have values assigned to them. These variables which are used within the function's definition are assigned a value when the function is called, right? So think of them as placeholders. Okay, so these are variables, empty variables that you need to specify the values with, okay? So 3 corresponds to large B, capital B, 1 corresponds to B, small b, and 2 corresponds to h, right? So you need to define all this when you're calling a function, because there is no default value as seen in line number 2. The function arguments are defined, hence giving them okay. So actually, in certain cases, we can come up with the default values, but in this case, since we are just dabbling very early on, these are very early days of your introduction to a function, we would be looking into a function which has no default value, not yet, probably after this. Okay, so within functions, another crucial concept that you would need to understand is scope, right? The scope of a variable is a space within the code where that variable is accessible. So you have two types of variable scopes in Python and also in other languages, where variables can be distinguished into two groups, which are global and local. Probably you can think of, maybe Malaysia and also Asia as a whole, right? Or probably the world, I don't know. So global variables are accessible from everywhere in the code, while local variables are accessible only within the block of code where it has been declared, okay? So, okay, I know this is probably just me being a little bit hungry, but then you can think of the variable scope where you have global and local as your local McDonald's, right? So in Malaysia, we have something that's called nasi lemak McD, right? And globally, in global McDonald's, you wouldn't find nasi lemak McD because it's only declared in Malaysia in our very own McDonald's. However, you have other types of uh, internationally known dishes. Sorry, internationally known menus like Big Mac, filet o fish, right? So those are the types of global variables. But then the local variables, like we have here, you have the chendol McFlurry, I think, and you have the nasi lemak McD, right? So certain things are available within the function or locally. So in this case, your function is a bit like Malaysia, and the entire program is kind of like the rest of the world. Yeah, so global variables are accessible from everywhere in the code, while local variables are accessible only within the block of code where it has been declared. So I hope the local MACD and also the global MACD analogy makes sense, right? So for example, if we declare a variable inside a function, the value stored in that variable will only be accessible from within the function, which means you can only buy nasi lemak McD in Malaysia. You can't buy it in, say, McDonald's in Europe, right? Because it's a local variable. It's a local specialty, right? So this means if we run the following block of code, we will get an error, right? Oh, actually, is it this one? If I run print my variable, it will throw up an error, does it? Yes. So the reason why there's an error here is because outside of the function, my variable, which is equals to 1, or our nasi lemak MACD, is unrecognized outside of Malaysia. Unless you're like a diehard McDonald's enthusiast. Therefore, my point is, if it's inside the function and you print it inside the function and you return it and it has a value, but you try calling upon the my variable again outside, but globally it's not recognized. Yeah, because the name my variable is not defined at the global stage. It's only known to locals, or in this case, it's only known to the function, within the function. Okay, so let me just comment this out very quick. And we'll just run this again. Okay. So since the print function in line number 7 is trying to access the value of my variable inside our myfunc function that runs from line 2 to line 5, there's an error that is caused because it has been declared inside the function definition. Therefore, it cannot be accessed outside of it. Okay, so let's just see what happens if we modify this previous code block, and let's see what happens. Okay, so continuing the previous variable scope that we have. Okay, so this time around we have something called my variable, which is defined outside global. So this my variable at line number 2 is actually a global definition of our variable, right? So my variable inside globally is 5. But then inside the function, my variable is 1. Okay? So this can be attributed to something like, yeah. Oh, probably I can use the same analogy again, right? Like, for example, how Big Macs in Western countries are a little bit larger than what we have here in Malaysia. Like the burgers in McDonald's Malaysia, I think I saw it somewhere. Yeah, the sizes, the portion sizes are a little bit different. It differs from country to country, right? So like for example, like here, this my variable, which is probably a Big Mac in the United States of America, and this definition my function A has my variable of 1, so this is the Big Mac that we have here in Malaysia. So it has the same name, but also the portions are probably a little bit different from each other, but it's also, the same name, right? Just different definitions. Okay, so what happens here is that when we define my variable not equals to 5 globally, but then inside my function or inside Malaysia, we have my variable equals to 1, okay, in line number 4, okay. So as such, why did the my variable value display 5 in line number 7, right? So we call upon print my variable in this line number 7 here, okay. Why does it show number 5? Let's go see. If we run this, you would find that actually print my variable is 5 because line number 7 directly takes the my variable value from line number 2. Okay, this is because inside the definition my func, right, lines number 3 to number 5, the my variable that we declared as equal to 1, it only exists inside of this function, and as it goes outside of the function, this my variable definition is destroyed. Okay, so it's no longer existing in our memory. Because the my variable declared outside of my func, yes, which is line number 2, is distinctly different from the one that we declared in line number 4, yes, because both variables have different memory allocations, what happens within the function inside Malaysia stays within Malaysia, alright? And it's not really applicable outside, which is why you see line number 7, when we call upon print my variable, it points to the value number 5 because of, yeah, you can read my explanation here. My variable equals to 1 only exists between lines number 3 and number 5. Outside of it, because of the local scope and the global scope, right? In the local scope, my variable is known as 1, and as it ventures outside, it's no longer 1, it's destroyed. And instead, you would have to be content with the global definition, which is my variable equals to 5. Therefore, in this example, my variable created in line 2 is the global variable, and the my variable created in line 4 is a local variable. So this is the difference between global and local, okay? Hopefully you'll be able to digest this. It's okay, you can pause and rewind back if you don't really get what I'm trying to say. It's okay, probably play it a little bit slower, see if you can get your understanding right, but hopefully you'll be able to distinguish between these two, one which is a global variable, the second one is a local variable, okay? So we have, well, I think we have two two code blocks left, okay? So function parameters. The parameters of a function are what we put between the parentheses when we first declare it. When we call the function from elsewhere in the code, we need to specify a value for all of the parameters that appear in the function's definition. Otherwise, we will get an error, okay? But what if we want a parameter to always have a specific value that can be changed to something else only when needed? Do you remember our very first function, which is the calculation of an area of a trapezoid, where we only listed the input, which is the capital B, the small b, and the h, right? The three inputs that we need to calculate the area of a trapezoid. However, in this case, when we are trying to calculate the perimeter or the, so what we do here is actually we are trying to get the area and also the perimeter of a given circle, right? So within this definition, myfunc, you have the radius and you have the parameter equals to false. Right, in the very first function that we learned, we did not have any default values, but here in this code block we have two parameters that we want to use within this myfunc, right? And the second parameter has a default function. Okay, so what we're doing is essentially we are trying to define what is the radius of a given circle, and we set the parameter equals to false if we only want to get the value of the area of a circle. So here, let's go see the code block line by line. See, so first line of the function is we use def to denote that it's a function. The name of the function is myfunc. So the two variables or parameters that we're using are radius and perimeter equals to false. So this is the default, because if we set this as our default, if perimeter equals to false, then we return the value of a circle, of a circle's area only. Okay, so since perimeter is false, we return the circular area, or else if the perimeter is not false and we want both the area and also the perimeter of a given circle, we specify perimeter equals to true. When we specify perimeter equals to true, line number 3 becomes false and it goes to line number 5, and subsequently it runs this code. Okay, it returns both values, the area and also the perimeter of a given circle with a certain radius. Okay, so in order for us to demonstrate the function that we just created, okay, is that in line number 4 we call upon the function myfunc and we specify the radius, and we let it be that the perimeter is false. Okay, so when we run line number 8, we would find that actually the value is 50.24. Okay, now on the other hand, say if we want to find out what the perimeter value is like, right? We call upon myfunc, right? We call the function name, we specify the radius, but at the same time we want the perimeter calculation, perimeter value as well. So we change the default value of false to become true. Since perimeter equals to true, we skip line number 3 and go straight to line number 5, and we execute the statement that follows the else statement, and it returns the value of, first it returns the value of the area of the circle, and second it returns the area of the perimeter. Okay, so lo and behold, you would find that the area is 50.24 and also the perimeter is 25.12. Okay, so this is what we call a tuple, isn't it? Perimeter set to true. So this is actually a tuple, right? It's unchangeable, but you do the, what do you say, the comparison with the values inside the tuple, and then you return back the value of the calculated area and also the calculated perimeter. So as always, if you feel like my explanation is a little bit too wordy or lengthy, you will benefit from reading the notes that I have underneath the code block, just to have a better understanding of whatever it is that we just did. Okay, this is the penultimate code block. Okay, unpacking. When a function returns a tuple, you can unpack its contents and store each entry of the tuple into separate variables. So using the same function called myfunc defined previously, the output can be unpacked like this. So using the same function, myfunc, right? Using the tuple unpacking feature inside of Python, right? You have myfunc for comma perimeter true. So the first value that it returns is saved into a variable called area, and the second value that the function returns is saved into a variable called perimeter. So in order for us to confirm this, we can print area and print perimeter separately. So let's run this. When we print area, it shows 50.24. However, when we print perimeter, what will happen? You will see that it will show you 25.12. Right, so there's a difference between the area and the perimeter thanks to tuple unpacking, right? First one is area, second one is perimeter value. Okay, in line 1, when calling myfunc, so this is line 1 apparently, the output is automatically unpacked inside the variables area and perimeter. So this is the area, perimeter. Okay, so the conclusion here that we've reached upon hitting the 1 hour 30 minutes mark. Well, I'm glad it didn't hit 1 hour 45 minutes. Okay, this point we would have all the knowledge that we need to read and understand most of the syntax found in Python. Okay, the vast majority of Python programs use libraries. So all of the things that we've used in this particular notebook are the libraries that exist with a stock or a default Python installation. So for other chapters, we would need to install other libraries to expand the capabilities of the language. So for example, in this next chapter, we would use the most widely known library of Python called NumPy. And when you've successfully installed NumPy, you would be importing NumPy as NP. So this is something that we will use quite frequently in the next chapter. So thanks for joining me for part 2. I'm glad you made it so far. Hopefully this helps with your self-study journey. If you have any problems whatsoever, you can call me, you can message me, but then I do respond better to texts. Okay? All the best, and I'll see you in chapter 3. Goodbye now.